Thanks for stopping by to check out this episode of Vintage Audio Review. In this episode, I'm going to talk about this Carver M400a power amplifier, or as it is more affectionately known as the Carver Cube. Carver started selling this as the model M400 in 1979 at a cost of $349. In 1982, the Model 400A came out, and that was listed at $449. And a year later, it became the Model 400T, the T standing for Tube Transfer Function, and its price was also $449, which would be about $1,300 today. It was rated at 201 watts into 8 ohms from 20 hertz to 20 kilohertz, or 300 watts into 4 ohms at 1 kilohertz. The THD was listed at less than 0.05%. It's really a cube. It's about 7 inches by 7 inches by 7 inches and weighs just a tad under 10 pounds. It is very lightweight and claims to put out a lot of power. My introduction to the Carver Cube began when I read the 1980 November issue of Audio magazine, where they did a review of the Carver Cube, and they were very impressed by it. I decided that would be a nice amplifier to buy for my mobile DJ system that I was putting together. And I did purchase one in 1980. Here's a picture showing the DJ setup that I had, and you can see the Cube proudly in the stack of equipment. Now, I thought for sure I would not have any issues with a 200 watt per channel amp powering those nice efficient La Scala loudspeakers. However, one of the very first parties that I DJ'd at a dorm, it was a very large room, and after maybe 40 minutes of playing relatively loud, the music died. I had to wait about 5 minutes for the amplifier to cool down and resume playing with a little bit lower level, and I did not have any problems. Needless to say, that ultimately forced me to sell the M400, and I bought a Sound Craftsman MA5001, I believe it was, which was a 250 watt per channel amplifier, and it's one of those pieces of gear that I wish I still had. I digress. So let's fast forward many years, and when I was getting back into 2-channel sound, I decided it would be nice to have another Carver Cube. I thought it would be a good idea to reconnect with another Carver Cube amp because I no longer have a mobile disco business, and I thought the Cube would do rather well with the La Scalas at the levels I typically play at. So I believe I purchased this one off of eBay, and life was pretty good until I decided I wanted another pair of speakers, which ended up being the CAF 107s that I did a recent video on. And I thought it would be fun to have 2 Carver Cubes running as monoblocks, which would be able to put out at least 400 watts into 8 ohms. So I got another Carver Cube off eBay, and everything seemed to work. Although I was faced with some distortion when I played very loud. I wasn't sure if it was the speaker breaking up or the amp. And this particular amp shut down after playing it very loud. And it got very hot on the side, not to where you couldn't touch it, but it did get hot, and I just figured it was due to the thermal protection circuitry of the amp. It cooled down and life was good. At that point, I had another Sound Craftsman power amp similar to the MA5001, and I put that one in, and I took the Carver Cubes out and measured and determined that these amps needed some help. So the data you're going to see on this cube is after recapping. There is a small segment showing the actual problem with the unit that forced me to recap it. But honestly, if I played at low levels, other than the little low-level hum you have with no signal applied, they still would have worked okay, but I do play loud with the CAFs. Right now I'm going to show you the front and the back and the sides and the bottom, and then look at the data, and then I'll talk about its performance a bit and something special that I did with this particular cube. This is a closer view of the M400a, and really the only thing of note here, a big thing, are the 6 LEDs for the left and right channels. They provide a 40 dB dynamic range of power indication. They are weighted towards low frequencies, and in fact, when you check them according to the service manual, you should have the 0 dB light coming on when there was about 136 watts into 8 ohms of power at 200 hertz going on. Now this particular unit, the 0 dB light came on at 120 watts. When I was testing it at 200 hertz, there is no real adjustment for that, but that is just what I measured. Also, there is a fault strobe, so these lights will dim or flicker on and off. I've never had it happen to me, but it says they will flicker on and off if there is a problem with overcurrent draw or too much voltage, and when the condition is gone, it should come back to normal. That is a side view of the M400a, just kind of showing the venting. Now, you'll see in the video where I have the unit apart, this case actually acts as a heat sink. There's some heat sinks around that the transistors mount to, but this entire case is actually part of that heat sink mechanism, and the grease that is attached between that and the main heat sink gets messy when you take it apart, but that's just one of those things. So here's the rear of the M400a. Not really a lot of unusual things going there. It does have a replaceable 15 amp fuse. You do have your undesired but stock push-in speaker terminals. There are places on the internet, Neleon Audio I believe is one of them, that does provide an upgrade to those with regular, I call them three-way banana jack binding post kind of things. If you brought it in for service, you could upgrade that. And I looked but did not see anything specifically designed for the M400a that I could have put in there easily, or I would have done it. But to start grinding away or having to fabricate a little plate that you could mount banana jack binding post to, to me it wasn't worth it the way I use the amplifier. And then you have your unbalanced RCA inputs, and there's instructions on connecting it up as a monoblock amplifier as well. One other thing to point out is that the M400a is always on. That was the way it was designed. There's no power on-off switch, and I'm thinking that that might be why a lot of these that are 40 years old might have capacitor issues, because the capacitors are just always on, and they get maybe an extra workout for always being on. What I'm going to do now is show the original problem with the M400a that I have here, and then you will see some of the repair process that I went through to replace the capacitors and get this thing apart, and some things that I learned in doing so. It is not an easy thing to do. This amplifier is not very easy to work on, and there are some videos on YouTube that go into more detail about the repair of the M400 series amps. One of them is X-Ray Tony B, and the other one is Duality Repair. I kind of showed what I did. Had I watched the X-Ray Tony B one, I may have taken some of his advice about replacing multiple capacitors with single ones, and maybe even swap out the dual bridge rectifiers with a single one. That's actually a good idea. But I didn't replace the rectifiers, and I used the same caps that were in there with the exception of the big filter caps, and I'm sure I will get some feedback on the way I handled that. The capacitors that screw in were not available at the time, and I didn't want to wait any longer for those to arrive, so I did it the way I did it, and I'm very happy with the results. Plus, it saved me a little bit of money. That is always a good thing. I also did not choose to replace the spring clip speaker terminals with normal banana terminals, because it was just too much of a hassle for me to want to pull that block out, and it looks to me like you'd have to grind away metal to get a block to fit, or you'd have to get a piece of metal and make your own little adapter and then use regular three-way banana plug kind of speaker wire connectors, and it didn't make any sense for me, because I use a little adapter and I'm not unplugging or replugging in speaker wires very much, and so to me it just wasn't something that I wanted to get into at that time. Now I'm going to demonstrate the problem with this particular M400a, in particular with the left channel. So right now they're both, the left and right channel are doing okay. I'm going to go ahead and increase the level of the signal going into the M400a, which will be shown right there, and of course the output will increase as well. So right now we're looking okay. Right now we're putting out about 70 watts. We'll put out a little bit more power at 72 watts. We're still looking all right. And right now at 82 watts, we can see that it's still looking all right. Oops, right here at 9700 watts, we can see that our left channel distortion went way the heck up, and right now the amplifier has clicked into protect mode and killed the output going to the load. If I unplug it and wait a minute, it will be just fine. But that is the problem that is going on with this particular amplifier. I wanted to see how much better the right channel performs, so I am just displaying that, and right now we're at about 90 watts, which is about all the left channel could take. We'll increase the power slowly. About 100 watts, we're still doing good. The thing we want to look at is our distortion here and the THD plus noise over here. Right now we're 112 watts, we're still all right. 118 watts. We can start seeing these harmonics kind of getting a little bit larger there. And right now we're at 132 watts. And our source THD is looking good. THD plus noise is okay. And we are at 148 watts, and you can tell that our SNR has gone down and our THD plus noise has gone bad, and we're about ready to hit protect mode, which was right at that point. So the right channel definitely performed a bit better than the left channel. Once the covers have been removed, the next step is to label the transistors, or at least that was the next step for me, so I can put them in the same spot. Not that it would make any difference, but I'm going to put them all in the same spot they came out of. So the step following the labeling is to actually remove the 2 screws off of each of the 12 transistors. That is going to be fun. I finally managed to get the M400a apart to where I could get at the circuit boards, and it takes a bit of work because a lot of the nuts on it have, or the screws had thread locker on them, and some of them have very small heads, and it's just hard to get them loose. But now that I have it loose, this is one of the power amp boards here, and it plops into this socket right here. Well, not socket, it has a socket on it. I don't know how this will turn out. It's socketed here, and then that fits onto those pins there, and then underneath those pins is the power supply board. So you can basically get everything apart without having to remove the transformer wires or the wires from the triac down there. This is the component side of, I believe, the left channel's amplifier board, and I wanted to point out the 4 electrolytic capacitors that will get replaced, and there's 1, 2, 3, 4. Also, I will point out that this guy right here, this capacitor here, one of the legs got pulled out of the other side of the circuit board trying to unscrew the nut that was on this transistor here on this heatsink that was mounted to the chassis. So that will get repaired as well. This is the component side of the power supply board, and what I am going to be replacing are these 6 2200 microfarad capacitors, as well as the smaller electrolytics. I believe there's 6 of those. You can see the circuit board connection that connects to the right channel, I believe it is, circuit board through this connector here. In order to get this whole assembly out, I should point out there's 2 screws that hold the RCA jack assembly to the circuit board, and those have to come off as well. This connector right here is where the front LED circuit board connects to. At this point, I have recapped the power supply board with the exception of replacing these 2 caps here. Now these are the original caps. They're 4000 microfarad at 80 volt caps, and they have a screw terminals here, and I'll show you how they mount behind the board in just a moment. But the problem was, when I ordered all my caps, these were not going to be available for a little while, and they are also about 18 bucks each. So that would be a cost of 30 bucks for these. Well, they have some 4700 microfarad 80 volt caps with snap-in terminals, which are these 2 guys. They're about 7 bucks. So with a little bit of extra time on my hands, which I have, I decided I would go with these and solder on some, I believe it's 14 gauge wires onto the terminals, cover them with shrink wrap, and I'm going to mount them where these screw in. I'll show you that in just a moment. I'm also going to put a tie wrap between them and then mount them with JB Weld to the case, and I'll show that. Now this is my own personal amp. It's not being moved around, and I don't have any problems with doing that. Now I will say that these capacitors, I could still use them. I checked them. The ESRs are great, and the values are less than 4,000. These guys are closer to 4,700. So I'm going to gain a little bit more capacitance in the long run by going to these capacitors. But I just kind of wanted to explain that's what I was doing, and we'll see how it turns out. Right now I'm going to show you where they mount. The capacitors mount here and then down here. One capacitor's here, one capacitor's here. I don't know if this is going to show out, but they kind of fit like this. I will solder the wires. There's plenty of places to solder here and here, so the wires that are on these guys will get soldered to these 2 points, and then they will be JB welded down along the base here. So the capacitors will mount down in this area here, should fit right along there. So if you look at that screw right there, that is the most difficult point to get at on this disassembly, and particularly the assembly. There's just a lot of stuff in the way, and at least with my tool set I couldn't get anything around a nut. Normally there is a nut on there, and I ended up thinking outside the box and put the screw in and from this direction. So there is a Allen head screw. It's a 440. All these screws that mount to these 6 transistors that are held down. So there are 6 440 screws that hold the 6 transistors, 3 for each channel, and that one is the one that is really difficult to get off. It's a pain, and to get on, if you do it with the bolt on that side, is with the nut on that side is difficult. So I just put the Allen head, the 440 Allen screw through, and that's easy enough to do, and then put the nut on the other side and it works just fine. So that's kind of a little tip. I wanted to show how the 2 big filter capacitors ended up being mounted inside the M400a, and basically they are tie wrapped together as well as JB welded in between them, and then they are JB welded to the case. You can kind of see how everything is fitting. The M400a appears to be working and is adjusted, and before I put the case back over it, I wanted to just point out that these sides here, along the top part, and then along on the other side, that all needs to be coated with silicone heatsink grease in order to transfer the heat to the case over here. So that's all kind of the heat sink of this M400a cube, and that's going to be a little messy with that grease getting on stuff, I'm sure. Anyway, I just wanted to point that out. I mentioned earlier that I replaced all of the electrolytic capacitors, and when I removed them, I also test them. What I found was that most of them were good, with the exception of these guys right here, the C11. There's one here, and there's also one down here, C10. This is for the left channel, and those 2 capacitors are found on the right channel. 3 of the 4 were basically open, and one of the good caps was found on the right channel, which may be why that one channel worked a little bit better than did the left channel. Also, in the power supply, there are a bunch of 2200 at 25 volt capacitors, and all those tested low. They were around 1,000 to 1,100 microfarad each, although the ESRs weren't real horrible at all on them, but they had about half the capacitance value that they should have. The main filter caps that I pointed out a little while ago, these guys right here, C17 and 18, which are the 4,000 microfarad, 80 volts, those measured at about 3700 microfarad. Their ESRs were good on them, but they did have a little less capacitance than the 4000 microfarads. Here are a couple of THD SNR plots at 1 kilohertz with the M400a putting out 5 watts into 8 ohms. And this guy right here, the one on the left, is before the capacitors were replaced, and the one on the right is after the capacitors are placed. Now it looks much better. The particular thing to note are, here is our 60 hertz noise spike, 120 hertz, 180 hertz, 240, and so on. You can see that those guys are really reduced over here. There's one at 60 hertz, and then they're much smaller. And also the THD is not that bad. It's usually set over here by some of the harmonics on this side, but it's still a little bit better afterwards. But the SNR is about 5 dB, 6 dB better after the capacitors were placed. So that's kind of more of a visual indication with them. So this kind of gives a better feel for what the capacitor replacement did. Here is the frequency response of the M400a. It is showing that both channels are matched to within less than 0.2 dB, and at 20 kilohertz the frequency response is only down 0.5 dB. I don't think I've seen anything better than maybe 0.3 of a dB in everything that I measured as far as power amps. So this is pretty good, half a dB at 20 kilohertz. And there was a 1 watt specification that said it should be down 3 dB at 100 kilohertz, but I did not measure that. All of the capacitors on the M400a have been replaced, and a couple of the adjustments performed with the trim pots inside it for the biases as well as the plus B adjustment. There's 3 adjustments that were made. And so now we're going to see how we look at 100 watts, and I'm going to go ahead and turn it on. And we're at 87 watts, looking good. Up a little bit. And we're at 103 watts, 109 watts. So up to 120 watts. And we're still looking pretty good. And it'll go up to 200 watts, and it still has good THD, and the SNR is not too bad. So we'll go into that later, but I just kind of wanted to give a visual indication that the problem seems to be gone. Here we have the THD SNR plot for the M400a putting out either 198 watts for the left channel or 207 watts for the right channel into 8 ohms at 1 kilohertz. And we can see that the THD is better than 0.03%. We've got SNRs right around 90 dB. And the THD plus noise is varying between 70 or 81 dB depending on the channel. Also note that the gain is a bit over 29 dB. Now the specification for this unit was it had to have a THD of less than 0.05% at 201 watts. So it is meeting that requirement. The Carver Cube has a specification that when operating as a monoblock amplifier at 2 kilohertz into 8 ohms, at clipping it can deliver 500 watts. Well, here we have the Cube operating at 2 kilohertz with a output power of 508 watts into 8 ohms, and it's nowhere near clipping. We see the distortion is 0.06%. And the SNR is still 77 dB. That's decent. Also note that the gain is 35 dB. Here is the frequency response of the Carver M400a running as a monoblock, putting out 100 watts into 4 ohms. And at 20 kilohertz, it's down maybe 0.65 dB. And it has a slight dip at 20 hertz of maybe 0.05 dB. So overall, it looks pretty decent. The requirement for the M400a running as a stereo amplifier into 4 ohm loads is 255 watts at 2 kilohertz at clipping. And you can tell we are doing better than the 255 watts. We're nowhere near clipping. And while the THD plus noises are only around 60 dB, the SNR is still above 70, so overall it is meeting the requirement. Here we have the THD SNR plot for the M400a putting out 400 watts into 4 ohms as a monoblock amplifier. And note the frequency is 2 kilohertz, which is a bit unusual, but that's the way Carver specified it. And it said it should put out 400 watts at clipping into 4 ohms, and we are not clipping. Our THD is only 0.3%. The SNR is 65 dB and the THD plus noise is about 50 dB. That THD plus noise is not stellar, but we are putting out 400 watts from this little cube. Here we have the noise of the M400a with it hooked up to 8 ohm loads and the inputs shorted. It is basically about 95 dB with the exception of the 60 hertz hum that's maybe 85 dB down, depending on the channel. Here is the multi-tone response of the M400a, and it's showing a distortion-free range of between about 13 and 11 bits, depending on the frequency. Here we have the THD versus frequency at a couple different power levels with the M400a operating as a monoblock amplifier into 8 ohms, and the very worst case THD is about 0.3% at the very high end of the band. This plot shows the output impedance for both channels of the M400a, and they're pretty close to the same. There is a specification for damping factor for the M400a, which is 150 at 20 hertz. If you look at the value at 20 hertz and divide 8 by that value, you will get a damping factor of about 57. So the data shows that my recapped Carver cube really kicked butt as far as the performance coming out of this little unit. I think it met all of its requirements, the THD and the power. It's really impressive the amount of power that this thing can put out. So one thing I need to bring up is that when I am trying to get a lot of power out of this guy, say 250 watts into 8 ohms at 2 kilohertz is one of the specs, the Carver isn't wanting to see a steady state sine wave for very long, and so you have to gradually bring up the power level to get it there, because it will start lowering the power level on you. And that's part of its protect circuit, which it's got 3 of them in there, maybe 4 if I count the thermal, but it monitors for overcurrent, it monitors for over temperature, it monitors, I believe, for a voltage, as well as how long the device is playing high frequency music. I had to go back and look at the 1980 review where they mentioned that they were having trouble getting it to put out power at high levels. There is a way you can defeat the circuit. In fact, it's one of the tests inside there. I did not need to do that to do my testing. However, if I brought it up slowly and left it close to that and back down a little bit and brought it up, I was able to verify the performance requirements at the high power levels. I read the service manual on it, and it explained what was going on. Now, there is another thing that I wanted to bring up, and that is the difference between the M400a and the M400t. I think they may have a different finish, but as far as the service manual from Carver, there is no difference between the M400a and T from anything that I can see, other than the faceplate where one says A and T. I think it was a marketing deal. I don't really have any problems with it, but I don't think there's an electrical difference between the two. For my listening test, I hooked up between 2 different speakers, the Watt 3s, Puppy 2s, and the KEF 107s. I basically left the house for a couple hours and had this thing cranking pretty loud. There was stuff outside my house I could feel vibrating. I mean, not like earthquake, but, and I mean, I listened to it for a while, but then I did errands, and I probably had this little guy on for 5 hours with a bunch of music, and then I switched it over to the KEF 107s for another hour. I have some notes. Typically for the Wilsons, which are more efficient, they're about a 4 or 5 ohm speaker that was drawing about 3.5 amps. I have one of those little kilowatt power meters that you plug something into and it'll tell you the current draw and and even the power it consumed, but it was running at about 3.5 amps or less max when the music was playing. The highest LED that came on was the 5 LED. Also, the temperature on the outside the hottest I measured was 101 degrees F at that time. And my room temperature is about 65 F. So it's a little bit cooler here this time of year, but that was as hot as I got on this guy. Now, when I hooked it up to the 107s, which are still 4-ohm speaker and less efficient than the Wilsons, I was getting current draws of as much as 10.7 amps. The little guy was drawing. My sound pressure levels were in the 86 dB, maybe a little bit higher, and the heat sinks got up to about 127 F, not surprisingly, when I was playing it for maybe an hour or so with the 107. So it survived with either, and it did quite well. Nothing shut down. Like I said, I did leave the house for a while because I just wanted to play this loud just to verify that the shutdown that I was seeing when I was testing with sine waves was just the Carver circuitry doing its thing, but it never did it with music. So that's a good thing. And I honestly think the one shutdown that I had with this amp, before I swapped out the two M400s that I had with the Sound Craftsman, was due to the capacitor effect and just the distortion that was probably coming out, causing it to go into shutdown. Now, the LEDs will flash if it detects a actual short. I believe the shutdown that I experienced was actually due to heat on this guy and the thermal circuit breaker opening up. So, as far as the sound, this guy sounds just fine. It did well with either speaker. Since I just happen to have a pair of Jeff Rowland monoblock amplifiers lying around that I had just finished reviewing, I decided to do a little A/B challenge between the little cube and the two Jeff Rowland monoblock amplifiers, which weigh about 45 pounds each. They're rated at 100 watts into 8 ohms and 200 watts into 4 ohms. And back in 1986-87, they would have cost about $4,500 compared to $449. You're going to see a little picture of this messy setup that I had, and there's an A/B switcher, and basically you can switch between the two amplifiers. You just press the remote. Now, before I do that, I have you can kind of see it in the picture, maybe there's a calibrated microphone, and I run pink noise, pink random noise, white random noise, and then like 1 kilohertz test tone. And I balance the input to the Carver amplifier using a passive volume control that doesn't really cause any distortion to the signal. The Carver is about 29 dB of gain versus 25 dB of gains for the Roland, so I needed to make sure that the levels were adjusted correctly. And then once that was done, I could just switch between the two amps in the middle of a song, a beat, whatever I was doing. Boom, you might hear a relay click. This is an overview of the test setup that I used to do the A/B comparison between the Carver Cube and the two Jeff Rowland Model 3 prototype monoblock power amplifiers. Here is the A/B switcher, and we do have the remote for it right here, this guy right here. Here is a Carver C1 preamplifier. This is my Surfans F20 music source. This is the sound pressure level meter that I used during listening. This guy right here is a passive volume control, and so we've got the main out 2, which has the higher gain of the two pre-out stages, going into this, and then this goes into the cube, and then each of the Rolands are fed by the main 1 output, which has less gain than the main 2 output in my preamplifier. It has not been modified. And that's kind of about it. You can barely see one of the speakers back here, and I just kind of wanted to give an overview of how this testing went. You can see that the cube fit on top of the Roland. It's much smaller than these massive monoblock power amplifiers. And you know what? Not a bit of difference between the two amps. Yeah, you could say my hearing's bad or this and that. I tried it on 2 different speakers, midstream of Diana Krall singing something and a bass some real heavy bass dominant track. I honestly can tell you that you could switch between the two amps and you would not hear a difference, other than sometimes you can hear the relay clicking in the A/B testing device. But other than that, you would know which amp is on. And I listen to a lot of music, and at more loud levels, but different levels as well. And there was no difference between the Cube or the Jeff Roland. I was just impressed at the little Cube, and you see it in the picture. It's sitting on top of one of the Rolands, and it just sounded the same. It handled whatever I threw at it. Either amplifier did, either speaker. No difference between the real expensive Jeff Rolands and the Cube. I'm just impressed as hell. So I do have another Cube that needs to be recapped, and I'm real anxious to see what happens when I get that one done. I doubt I'm going to do a video on it at all, but it's going to hopefully power the system where the 107s are hooked up to as mono blocks. Anyway, so that's kind of my little review of the M400a. Thinking back to when my M400 died at that party, the M400 had some changes made to it to get to the M400a, and I'm just thinking that there was maybe a little bit of issues with that particular amp at that stage, because there's no way they should have overheated with those efficient La Scala speakers, thinking back about it. So once again, I thank you for watching. I'm sure I will get a comment or two, and I like to see them, at least I have so far. If you have not subscribed to the channel, that would be nice, and if you like the video, hit the like button. And until next time, have a great day or night.